Hey everybody, it's Mrs. Mancuso. Last week you learned all about hydrocarbons. So hydrocarbons, just like the name implies, they only have carbon and hydrogen, and you learned about the homologous series of hydrocarbons, which are alkanes, which have all single bonds between their carbons, alkenes, which have a double bond, and alkynes, which have a triple bond. And you learned how to name them and write the formula and draw them. And this week, we are still doing organic compounds, but now we're going to do different classes of them. And what that means is, like, if there is an alcohol, that means it has an OH on it. So it's not just carbon and hydrogen anymore. We're going to add in elements like oxygen and nitrogen. And then the unique functional group is what allows you to say that they belong to that class. So really what this is all about this week is learning how to use table R, identify the class that a molecule belongs to it, name it, draw it. That's our focus. So we're going to start off here by looking at table R. If you do not have a reference table at home, you do have the ability to just Google it, and if you type in Regents Chemistry Reference Table, it'll come right up. So here's table R. Everything you need to know is on here. The functional group, that is the unique identifier. So when you see a molecule, like I'm just going to draw one. So here's a molecule, and when I look at it, I notice right away it's got something unique. That unique thing is called a functional group. So then I go down the list until I find it. And so this is an alcohol right here. And when I go to name it, I look at the example of how they named it. So they have 1, 2, 3 carbons in it, and 3 is prop. And here's the OH, and you always count from the shortest side. So this is carbon 1. So the OH is coming off the first carbon, and then the ending is anol, A-N-O-L. So this one, I have 4 carbons, so this is bute, and then I put the same ending on it, anol. And then if I count from the shortest side, this would be a 1, so 1-butanol. So I'm going to show you how to do each of these different ones one by one. So we're going to start off. You'll notice I've just cut each line of the reference table to show what that class is. So this one's called a halide. So I'm going to draw one. So I've got 5 carbons along it, and I'm going to have a bromine here and a bromine here. And so I could circle my functional groups, and that lets me know that it's a halide because it has a Br on it. Anything from group 17 is going to make it a halide. And then I look at how they named it. So they have 1, 2, 3 carbons. The Cl is coming off the second carbon, so that's where the 2 comes from. It tells you where the chlorine is, and they write chloro, and prop because it has 3 carbons. So the name of mine, 1, 2, 3, 4, 5. So 5 is pent, and then the ending is just ane. And then I have 2 bromines. One is coming off of carbon 2, and one is coming off of carbon 3. So my first name would be 2, 3. You remember from when we did branches before that if you have something twice, you can just write di. So dibromopentane. There it is, 2,3-dibromopentane. Let's do another one. What if the name was 3-iodohexane? So hex tells me 6. So 1, 2, 3, 4, 5, 6. 3-iodo, so carbon 1, carbon 2, carbon 3. Off of the third one, I have an iodine. And the rest of the open spaces are just hydrogens. So that's how you draw it. All right, next one, alcohol. So this is the one like I just showed you. I'll draw a different one. All right, and I'll put the OH here. So there's my functional group. That's what lets me know that I have an alcohol. And then to name it, 1, 2, 3, 4, 5, 6, 7. 7 is hept. and then the ending is anol. So I always just look at the example of how they named it. And then I have to count from the shortest side. So I'm going to have to go from this direction. So 2-heptanol. So the second carbon gets the OH. And here's another example where I give you a name. So let's say I have 2-butanol. So bute tells me 4. 1, 2, 3, 4. Enol tells me that it has an OH on it, and 2 tells me the second carbon gets it. So here's my second carbon, OH. And then I fill in the rest of the spaces with just hydrogens. All right, next one. This is an ether. So an ether just has an oxygen in the middle of it. So I could draw 1, 2, 3, and then an oxygen, and then 1, 2, 3, 4. And so that's an ether. It has an O in the middle of it. That's the functional group. And then I look over here at how they named it. They have 1 carbon, and then they have the O, and then they have 1, 2 carbons after it. So a 1 carbon is a methyl, and a 2 carbon is an ethyl, and then the last name is an ether. So they basically named the branch on the left, and then the branch on the right, and then they call it an ether. So I'm going to do the same thing here. 1, 2, 3 carbons, so that's propyl. And then this one has 1, 2, 3, 4, so that's butyl, and then ether. There we go. And so if I give you the name and want you to draw it, let's say I have methyl propyl ether. Methyl means 1 carbon. So there's my 1 carbon branch, and there's my oxygen. And then propyl means 3 carbons, so 1, 2, 3. And then I put the H's on it. Now, oxygen, you will notice, has 2 bonds, which is perfect because oxygen has 6 valence electrons, so it can form 2 bonds to have that 7-8 to be stable. All right, next one is an aldehyde. So an aldehyde is at the end, and so this ending carbon has a double bonded O and an H on it. In the example, 1, 2, 3 carbons, and then the double bonded O and the H. So 3 carbons is prop. Anol is the ending. So if mine looked like this, this would be an aldehyde because the double bonded O and the H are on the end. And then I just counted up 1, 2, 3, 4, 5, pentanol. And that's it. There's no number in it because it's always on the end. An aldehyde always has the double bonded O and just an H on the end. So let's say I have butanol. Bute means 4. And the last one has this. Put the H's around to make sure all of your carbons are complete. There you go. All right, next one is a ketone. So a ketone, this carbon is not on the end, it's in the middle. So having a double bonded O off of a carbon somewhere in the middle of the chain. So let me draw that. There we go. So I'm going to look at how they did it. 1, 2, 3, 4, 5 in the chain. So that's how they got pent. Unknown is the ending for a ketone. And then 2 tells me where the double bond is. So now I go to mine. 1, 2, 3, 4, 5, 6. So that's hex, unknown. I always just use the same ending that I see there, hexanone. And then this is carbon 2, where the double bond is. So 2-hexanone. All right, and let's say you have to draw 3-pentanone. So pent is 5. 1, 2, 3, 4, 5. And 3, 1, 2, 3 tells me where the double bonded O is. And I go around and put my H's. All right, on to the next one, an organic acid. So this comes up a lot in food. All of the proteins that you eat are made up of amino acids, and amino acids are called that acid because they have those on the end of it. And also any fatty acids that you eat also have that ending to them. And so let's do pentanoic acid. So this time I'm actually going backwards. I'm telling you the name and I want you to draw it. So enoic acid lets me know that it's an organic acid, which means I've got to put this carbon double bonded O with an OH on the end. And Pent tells me to draw 5. 1, 2, 3, 4, 5. And then I do the ending, double bonded O and an OH. There it is. That's it. So I actually love drawing these things. Like this is a unit that I really enjoy. I think it's fun to do. The next one, let's say 1, 2, 3, 4 with this at the end. This at the end lets me know right away that's an organic acid, and 4 is bute. So butanoic acid would be the name of it. All right, next one, an ester. Okay, so an ester has this double bonded O and an O, but it still has part of the chain here and it still has part of the chain here. So this functional group you find like in the middle of a molecule. So let's draw one. All right, there it is. And now in order, see, I see that functional group, and that's what lets me know this is definitely an ester. And then I go look at their example. So methyl is the branch. And so the branch is what comes after the oxygen. So there it is. A methyl is a 1 carbon, so there's a 1 carbon branch after it. And so I look at mine. Mine has 2 after it. So 2 after it would be ethyl. And then the last name, propanoate. Prop tells me 3 carbons, 1, 2, 3. Anoate is the ending for an ester. So I look at mine, 1, 2, 3, 4. So that's butanoate. So the name of this is ethyl butanoate. Ethyl is my branch, butanoate is my chain. All right, I'm going to go and do another one. Let's call it propyl hexanoate. All right, hex tells me 6. 1, 2, 3, 4, 5, 6. Do the double bonded O, do the O. Then propyl tells me that my little branch coming off of this O has 3 carbons. 1, 2, 3. There it is, and I can sit here and put all the H's on it. There it is, propyl hexanoate. All right, next one is an amine. An amine has a nitrogen in it. So let's go like this, 1, 2, 3, 4, and let's put a little nitrogen right there. And let's look at how they named it. 1, 2, 3 carbons, and then a nitrogen after it. So 3 is prop. Anamine is how you name it, and then 1 tells me that this came off of the first carbon. So let's look at mine. 1, 2, 3, 4. So that's butanamine. So I just use the ending just like that. But because I have 4 carbons, and it's coming off of carbon 2. So I do need a number to show where the nitrogen is. 2 butanamine. All right, let's do one where I give you the name. So let's say I have 3 hexanamine. So anamine tells me I've got a nitrogen in there. Hex tells me 6. 1, 2, 3, 4, 5, 6. And then the third carbon gets the nitrogen. There we go. And then I would put the H's on it. Next one, amide. So an amide is at the end again. Here's the rest of my chain, but here's the ending. So my molecule goes like that, and it ends with a double bonded O and an N with usually 2 H's on it. So I definitely know this is an amide because I have that ending. And then theirs was prop because it has 3. And you do not need a number because it's always on the end. So mine is 1, 2, 3, 4. So that's butanamide. That's it. And now I'll just do another one for you. Let's do propanamide. So prop is 3. 1, 2, 3. And then the double bonded O, and then the N. And there it is. I could put the little H's on it. I could put these H's on it. All right. And so what I want you to do is there is a practice packet. And the practice packet, you can either do where you go and you download the document and then you review it and you write right on it and then give it back to me, and go ahead and draw right on the document. I want to be able to see it. And if you can't draw on the document, then draw it on paper. So I'm not sure if you're able to print from home or not, but I don't care. Just take a regular paper, draw them, and send me the pictures of all of them. I want to make sure that you can draw and name and identify the class. So for example, let me just do one with you. Let's say this is my molecule and it's got this double bonded O in it. What I expect you to be able to do is say, hey, that's my functional group. And then you go to this table and you find it. There it is. That lets me know that this is a ketone. And so the class is ketone. And then to name it, 1, 2, 3, 4, 5. So that's pent. Unknown is the ending for a ketone. And then carbon 1, carbon 2, carbon 3 is where the double bonded O is. So 3-pentanone. All right, so that's what you're going to do with the practice sheets. Please message me if you have any questions, and remember that every Friday we Zoom to go over questions that you have and just sort of catch up with each other. All right, have a great day, guys. Miss you.